Welcome back to Living in the Real World. Today's topic is something that's going to seem very obvious to many of you, but seems kind of counter to um, current cultural and economic thinking. I'm going to make the argument that the most eco friendly products are the ones that are durable, long lasting, and easy to maintain. So, the greenest products are the products that are built to last. And so let's get into it. So, why does a long service life or product longevity matter? So, every time we create a replacement, we're adding, there's raw material extraction, manufacturing process, packaging, transportation, and what's often not accounted for is the disposal of the product into life. So, there's energy used at every one of those and impacts to the environment. Um, Longer lasting products, so reduce total material consumption, embodied energy, which is a term we're going to get into, the emissions and landfill waste at the end of the life, and for you and me, ownership costs. Um, it requires more than just durability. It also depends on efficient operation, reliability, repairability, and affordable um, replacement parts and labor. So the repair process is affordable. Um, Newer products may use less energy, um, and this is an argument that's often used why we need to upgrade, get new products. But I don't think they give us the information. We do analysis on the full life cycle cost replacement. Um, Designing products that remain useful for decades may be one of the most practical ways that we can reduce environmental impact. So, what are the keys to long service life? It's got to be durable. Um, Materials you know, can withstand the intended use of that product throughout its lifetime. Um, Efficient, so it doesn't use a lot of energy or resources through its working life. When it does have a problem, it's easy to repair and therefore cost effective. Um, the maintenance is easy to keep up with. You can diagnose the issues and repair it. You know, it doesn't require a lot of specialized equipment. You don't need to drag you know, some scanner in that costs $40,000 to figure out what's wrong with something. And the parts are readily available. So, and then at the end, um, it's recyclable. The parts can be reused again. Um, and this, some we'll get into a little bit. Some materials can, some can't. So we want to minimize the landfill waste and the hazardous materials, the stuff that can't be reused and requires expensive um, disposal costs. So what this doesn't mean is just over engineering stuff and using a lot of excess materials, because that doesn't necessarily ensure a long life, and it adds cost and energy at every step. So build something heavier, it takes more materials. um, then the operating costs can be heavier, the transportation costs. So this is all stuff we'll get into, but that's what it doesn't mean. So why are we doing this? We want to use less of our valuable resources, save energy. We have a news articles every day. You see the strain on our electrical grid and all our gas supplies, all that. We want to reduce emissions and other environmental impacts. Reduce supply chain pressure. This is something we've seen over the last 5 or 6 years. The supply chain is not as robust as they want us to think it is. So, and in the end, we want reduce the total cost of ownership of things for us. So sum that all up, we want a better life for people and we want to protect the planet. So that's why we're doing it. So this, when we replace a product, every product goes through this. Um, Called the hidden energy trail. At every step of the process, when you're pulling the iron ore out of the ground, or cutting down the trees, or pulling the copper out, whatever it is, um, energy, materials, and labor go into that, and emissions and waste come out at every step. And some of these steps, there's multiple processes. This, pull it out, the processing may go through several steps. Building the product, think about like something complicated as an airplane. um, this could be happening on multiple continents, the components, and shipped around. The ship to sell, here's, this is just not necessarily one step. We got distribution, it may go through several steps. um, Use and repair, and then the end of the life. So there's every step energy going in. So the longer a product lasts, we distribute that, what we call embodied energy. So that's the that's the energy that's spent whether you turn a product on or not, and also accounts for the disposal at the end of its use. Um, the operating energy is the energy that a product uses while it's working. So if we can make it last longer, we can spread that burden out over years. But not every product is the same as far as where it uses the most energy. We're going to look at that next. So here's three examples of studies I found. So when you think of something like an office furniture, pretty much all the energy goes in the production, a small amount, to transport it to you, and almost none in use. So this is clearly, if you have a cheap particle board furniture that you have to replace every couple of years, you know, all that energy is just keeps getting repeated. Whereas you have quality piece of furniture that lasts 50 or 100 years, then that's distributed out. Um, Very clear. Passenger car, a vehicle, that's just the opposite. Most of its energy is used during its operating life. Um, and this one really surprised me. Desktop computer, and I think this could be, extrapolated out to a lot of the other high tech product, phones and things like that. Most of its energy goes in the front. So when we're replacing these things all the time, and they also have, they're not, a lot of them are not very recyclable, a lot of hazardous materials, things like that. So this can really have impact. Another way of looking at it is, so think about refrigerators. This is something, I hear it, probably you do too. Everyone says, oh, they don't last like they used to. And I don't have that data, but what I do know is we sell like 9.5 to 10 million refrigerators per year in the United States. They're sold. Um, the average lifespan is around 12 years, and the average cost is about $1,100 per unit. So, what if we increase that life by 30%, just under 16 years? That means we reduce the replacement demand by about 23%, or just over 2 million units per year that don't have to be manufactured. So for you and I, we could say, oh, that's good news. I don't have to buy one as much. Um, we're not filling up landfills, but I think you can see the issue is the big business is saying, oh, I'm not selling as many. So I think that's the key to the whole thing right there. And we'll talk a little more about that. But another thing, car tires. About 264 million tires reach their end of use in the US. Now, 207 million are recycled or used as fuel in industrial processes. So if we saved 30%, made the tire last 30% longer, um, 60 million fewer tires disposed of every year. And look at that, 64. about what we can handle. Um, Now, this is something looked at ships. So the data shows that ships are being used longer, so their service life has been getting longer. Um, on average, there are some exceptions, like container ships have actually shortened up because um, the newer ones, they're making them a little more fuel efficient. They can add more containers to them so that it helps the whole economic um, picture. But this is oil tankers, crude carriers, product tankers, bulk tankers, container ships, all of that um, in there. So, and I think this is a really good example for what I'm saying here, because the purpose of a ship is just to make money. That's it. If it's not, it doesn't have cargo, it's not making money. It's not moving. So obviously, using them longer is profitable, or they wouldn't be doing it. But I think one thing that's different from most of the products that you and I buy, are told we need, on ships, it's a different game. It's the owners have a say in the design. They're the ones going to the naval architects and marine engineers and saying, this is what we need a ship for, design it for us. It's going to go on this route, has to be able to go this far between, fuel, it has to go this speed, it needs to carry this much, it needs to, have this crew quarters, it needs to have all this stuff, and then find someone to build it. So they're in charge of it. Um, with inside there are regulations and stuff, but basically they're in charge. They're not being dragged into a shiny showroom saying, "Oh, this is what you need for a ship." And so we're, I think that's a very key point. And there's another way of looking at it. Um, just again, looked at a refrigerator. This is over 50 years. So, a person's time owning a home um, right now, and this is the dollars. This is in future dollars, and it's a 3% annual inflation, which I think we all know that that's way low than what we're actually seeing and have for the last 5 or 6 years. But we're just going to use those numbers. So right now, similar, 12-year average life, you're gonna have to buy four more refrigerators for a cost in the future, $12,600. So we go just over 30% to a 16 average life. Now you buy three. So in present dollars, you bought one less. You saved $1,100. Um, Future dollars, you're about $10,000, so almost 20% you've saved. If we can go to 18 years, 50%, now you only buy two and you've spent $6,000, or about 51%. So that's a good visual representation of how many less refrigerators are going to be filling up the landfill and you're going to be paying for. So some will say that the cost of the savings in electricity and other products, water or whatever it is, gas, the advancing technology will negate the costs, of keeping. So basically, if you buy this new efficient one, you're going to save money versus, and that may be true for some products. I mean, my response was show me the data. Also, if we look back, compare a 50-year-old one to today, from the first generation to the second generation, maybe, but between the fourth and fifth generation, I don't know if that argument's valid. It's probably just added more, whiz bang marketing features onto it. So, show me the data for that one. Another thing that recyclability is a marketing scheme that you'll see products, especially like Apple. Oh, buy ours, it's recyclable. It's got this nice aluminum case, um, but they don't talk about it lasting any longer, and still want to sell you a new product. So um, beware of that. So if we want to do this, what do we have to do? And it all starts in the design of the product. Um, low need a long life, low energy design. So it's got low embodied energy. Um, we talked about that. We can use fewer responsibly sourced products, um, less energy to build it. It's got durable components, materials. So it's designed to last for its intended purposes. We see a lot of products that are just not designed to last. They get cheap plastic that breaks. You know, there's all kinds of examples. But it's efficient over its lifetime. Um, Again, it's reliable. It's gonna do what you want it to do for a long time at that performance level. You know, so and then I mean, not everything's perfect. Mechanical things, electrical things, they are gonna break. So we need to design for that also. Um, it's got to be practical and economical to repair. So what does that mean? That means you can diagnose and troubleshoot it. You can easily tell it's component A or component B. Um, and I don't need, $40,000 computer or other special equipment to do that. Um, Parts can be replaced easily. I don't have to remove the radiator to change the spark plugs. That goes into the maintenance. Maintenance is not going to get done. It costs too much. Total cost of ownership increases. It's affordable from both. Um, the parts are available. The parts are reasonably priced. The labor is not excessive. It's easy to find someone to do it. Um, that's the need to think through that. And a lot of products are actually replaced because it's not economical to repair them. Um, think if you have an engine problem on your car. A lot of cars, if it's older, it's going to cost more than the car is worth. You can buy a new one, you can get a warranty, you can get um, great financing options, and that's how it's designed. So repairability is big. Um, you often, and then it's designed to recycle. It doesn't have a lot of hazardous materials. It can easily be broken down. Um, doesn't have a lot of hazardous stuff. So at the end of the life, it can be the materials can be reused for something else, and there's not a lot going to the landfill. One thing, if you're familiar with this, you may hear a lot about design for manufacturing and assembly, and that's great. That's at the manufacturing level, and it saves them money, which is not often passed on to us. And a lot of times, it involves reducing the part counts, but things like that, so they can save a few pennies on millions of items. But then, you know, for instance, the part is glued together, doesn't have fasteners that screws or bolts that so you can pull it apart and actually replace something. It's not repairable. It's been sealed up together, some fusion welding process or something like that. Um, so we need to design for repairability. Um, Needs to be more used more than designed for manufacturing assembly. I mean, obviously they both need to be, but they need to work together. Another thing that I see a lot in industrial um, machinery equipment. That's my background for 30 years, and oftentimes you keep the the, the frame, the steel, things like depending on the machine, and then just every 10, 20 years, depending, update the electronics or moving parts, things like that, built to be industrial products follow this model a lot better than consumer products. So what's the justification that we're told why we need to have new ones all the time? Energy efficiency gains, which I think is very valid. But again, I have talked about this, which generation are we comparing to? Um, just don't see many studies that show us the total life cycle cost in embodied energy. Um, Convenience, it's got larger capacity or features that you want. That's a personal preference, and that might make sense to get something new. But if products are built longer, then you're the one you're getting rid of has more value, and it can go on to somewhere else. Um, you know, replace supports the economy, like that example we used, the refrigerator. That's, well, what are you going to do? You're going to shut down, lose jobs. Um, the whole story. You're going to collapse the economy because people aren't buying things. But you know, at some point, there's a tipping point, and once you destroy the environment at a point, it doesn't matter. You don't have economy. You're never going to have an economy. So this is a short term complaint. And probably valid on the short term, but I think we need to think longer term. Changing lifestyles and trends. This may be true. Smaller families don't need large capacity of things. Um, you know, different things. But I think a lot of that is influenced by marketing and media. The trends always change. Think of stainless steel appliances, stuff like that. But one way to get around that is, why don't you offer, the visible part of the whatever it is that you can change them out. But new ones like covers on your cell phone, things like that, um, rather than replacing the entire product to address these issues. So what can we do? So if you're involved in designing products, building products that have some influence or something, then start using the principles we discussed in design. And if you're a consumer, let's start demanding long-lasting products. And um, easier said than done, and probably means going with smaller companies. If possible. Some things aren't, but I think that's something we need to use our collective voice to start demanding this. So, in summary, um, products that last are the most eco-friendly. Long service life is durability, efficient operation, easy, affordable maintenance and repair, and then it's recyclable. Um, Cost of repair makes the replacement better, better in the short term, economic sense. Um, but replacements just, we see the hidden energy trail. We keep that embodied energy. Um, so a moderate, we saw the example of the refrigerator, the moderate increase in service life greatly reduces the number of units that need to be manufactured, replacements. So operating efficiency, may justify, but really need to look at that in depth, the whole life cycle. As a designer, prioritize longevity and repairability, and as a consumer, demand that that's what you're getting. So some topics, and please let me know if this is something you like and you want to look into this more. Um, some more topics on the same general topic is, how to analyze this to really see if what makes sense, like life cycle analysis, and there's some others we can look at. um, Recyclability, what materials are recyclable, how many times can they be recycled, what is being recycled, how much energy does it take to recycle, and the energy efficiency proof. So those are just some thoughts that I had if you want to see this going deeper. And anything else, please let me know. So, um, want to thank you for tuning in, for watching, and please pass this on to anyone that's maybe interested in this topic. And going to be hopefully coming out with some more soon on similar but similar topics. Please like this video. Please subscribe to the channel, and any feedback that you have, good, bad, suggestions, things you want to see, please let me know. So there's an email, livingintherealworld@proton.me. So thanks for watching and have a good day.